Hey guys, welcome back to another episode with me, Budget Gaming HD. In today's episode, I will be teaching you guys how to make your very own 5-volt regulator. So you don't want to miss that. Hey guys, so in today's episode, I will be teaching you guys how to make your very own 5-volt regulator. This is a DC current system. It takes anything from 17 to 12 volts and converts it to 5 volts. The difference can be up to 0.03, so I'm looking at 5 volts, 0.03 and maybe 497 volts, give or take a few, of course. And then I'll also show you guys how a breadboard actually functions so you can use one at home. So without further ado, let's kick this off. So this is called a breadboard. As you can see, it's got various lines up and down going from plus and minus, A, B, C, D, E, E, F, G, H, I, J, from 1 to 30 at the bottom. There's various types of breadboards. However, this is a very simplistic one. Basically, this bus over here allows plus and minus to range right through to the end. There's positives and there's negatives towards it. You will learn this as we go along. And if you have your own breadboard, you know what I'm talking about. The same with this side of the breadboard. It's also connected to one bus. So it's a complete positive on this side and a complete negative stream on this side. Some breadboards are made so that this is broken up and this is broken and this is broken. So if you want to connect these two, you need little jumper cables like these. So in essence, the other breadboard would look something like this if you want to jump between the two positive sides. However, luckily for me, with my projects, I don't need to do this because these buses are connected, as I've mentioned, as one. And then you get your little lines up here. They're all connected in one single strand. So A, B, C, D, E will be one plate. E, F, G, H, I, J will be another one. Okay, let's start to assemble a 5-volt DC regulator. You're going to need a breadboard. Next up, you'll require a LM7805 100 UF electrolytic capacitor, a 407 electrolytic capacitor, and a 4.7K resistor rated at 0.15 watts. Before we start this tutorial, here's the schematic of this voltage regulator. Okay, let's start assembling this breadboard. As a first step, I want to have my positive in. So I'm going to use the second port of my positive bus and plug it into the second bus of my breadboard, like so. The first one I want to keep for when I want to input my voltages. You can do it from whatever side, but I like to keep it logical from up to down. But as you wish, you can do it your way. The second step is obviously to use our 470 UF capacitor. Just make sure you distinguish between the anode and the cathode. I generally remember the shortest leg is to ground, so shortest leg would be negative. Next we're going to use our diode. Now generally they have a marker somewhere on the diode to indicate the flow, electron flow of direction. So just make sure that you understand where it is, and if you don't know, please refer to your manufacturing website. Not sure if you guys can see there, but there's a tiny speck of silver on there. So that means electron flow like this, but it won't go backwards, right? We want to jump with our breadboard into our next bus. Essentially, you can do this how you want. You can be as creative as you want. You can even work down. There's no set rules to this as long as it's connected in a logical order, right? So as you can see, we're jumping like that. Next, we're going to use our 470 UF capacitor. I always remember it shortest leg to ground, so shortest leg would be my negative, but you can remember it the way you want to remember it. Just make sure you understand what is your cathode and your anode. So we want to connect the long leg, which is the positive side, to the diode, right? So it flows over like this. Next, we need to use our LM7085 MOSFET. Comes with 3 legs, pin 1, pin 2, pin 3. This is known as gate, drain, and source. And if you do not understand what your MOSFET is for, please refer back to the manufacturing website. So pin 1 connects to the positive side of the capacitor and pin 2 connects to the negative side, like so. Pretty straightforward so far, nothing technical, as you guys can see. Anyone can do this, it's pretty straightforward. Next up, what we need now is our 100 UF capacitor, like so. Now this connects to port 3 and port 2 of the MOSFET. Remember, positive side, negative side, always remember you understand what it is. So the negative will go to port 2 and the positive will go to port 3, like so. Now on this positive side of this capacitor, which is at COM port 3, we need now to put in a little bridge cable that will become the positive for the 5-volt DC out. As you can see, I'm leaving one open here. This is where my multimeter will be plugged in so we can test if this is actually working. Now my DC out negative will be on my port 2 of my MOSFET, like so. This will become the negative terminal. There you go. It's nice and easy to have these little jumper cables. You can logically just jump wherever you want to be. And now the negative for our DC 12 volt in will be on COM port 2. And there we go. There's the circuit completed. Now let's test the circuit just to make sure it works. For this test, I'll be using a 9 volt battery and a multimeter. I've plugged in my multimeter. As you can see, all the cabling has been done. A little bit of insulation tape to keep everything in place. And now reading on my multimeter, it shows 5.05. I would say this is a great success. So that's a wrap for this episode, guys. If you enjoyed it, please remember to like and subscribe and hit my ding dong to stay up to date with my latest content. I'm pleased to announce that if you like these little projects, I will be doing more of them. I'll be swaying a bit away from computers as this might be getting boring for this channel, and I'm on a venture of teaching you guys how to do basic electronics. The episode coming up, I don't want to give any spoilers. You guys have to wait and see, but let's just say the next project has got something to do with a step-up transformer. So you don't want to miss that.